Hello, welcome to Flip. So today we are on the topic of homologous series, and this is the learning objective. We will be talking about them as a group of compounds with a general formula, chemical properties, and their gradation in physical properties. Okay, we'll discuss that later. But let's begin with the Cartesian family. So this is the Cartesian family, as everybody know. I'm not sure which is who, but there are 6 of them here in this picture. 1, 2, 3, 4, 5, 6. So they are family because they show, they have the same names, right? They have similar names. Okay, Kim Kardashian and I don't know what's the rest. I think this is Kim Kardashian, right? I'm not too sure. But so like I said, they have similar names and they perform the same jobs. So basically, they're all in the entertainment industry. Okay, so they are a family. And if we extrapolate this idea into chemistry, it's the same thing actually, because a homologous series, it's also another word for family of compounds. Okay? And in each family, they have actually the same general formula. Okay, I'll explain that later. And they have similar chemical properties. That means they do the same thing. Okay, let me just give you two groups that we will go into details later. First is actually alkanes. Okay? Alkanes actually look like this. Okay, with a C in the middle and 4 H's at the side. This is its brother, okay, in a sense. Now with 2 C's and 6 H's at the side. Okay, this is the first family. Second family is called alkenes. And now it's looking a bit different. Okay. There's 2 C's now with 4 H's. Okay, and another one would be this. Okay. So you can see that they look different, okay, from each other because they are from different families. But if they are in the same family, they should look similar with maybe just differing H and C's. Okay, and that's essentially what's a homologous series. Basically, they have the same general formula, and they have similar chemical properties. That means they react with the similar things to a certain extent. Okay, so hopefully that's clear for homologous series. Now we'll move on to its physical properties. Okay, physical properties, we can use the Kardashians again, if it helps. Okay, so for example, there's maybe this, I don't know, this Kardashian 1, Kardashian 2, Kardashian 3, and Kardashian 4. Okay, so imagine that they each carry different numbers of carbon. So okay, they're all females, right? I think. So there's four of them. They each carry different number of C. She has 1 carbon. She's carrying 1 carbon. She's carrying 2. She's carrying 3. She's carrying 4 carbons. Okay, so to visualize. Okay, so there's 3 C's, 4 C's surrounding her. Okay, so what do we mean by this? This is called gradation. As the number of C's increase, okay, the properties will actually change. Okay, the properties in terms of melting point, boiling point, viscosity, and flammability. Okay, this is true for all families. Okay, be it alkanes, alkenes, alcohol, or acids that you will learn later. Okay, as the number of C's increase, okay, let me just write short form here. As the number of C's increase, what does it mean? It gets heavier, right? So the size of compound increases, which means it increases viscosity. Okay, viscosity really just means how thick something is. Okay, so as the number of C increase, okay, imagine it's from this very small thing, it becomes this huge puddle here. Okay, so obviously it becomes thicker and it's harder to move. Okay, so that's what viscosity means. Okay, how thick something is. So back to this, as number of C increase, the size will increase, viscosity will increase. Now melting point and boiling point will also increase, alright, because it's bigger now. So imagine if you had to burn a piece of paper versus if you have to burn one whole tree, alright, which one gets on fire easier? Obviously, the paper, alright. And so that leads us to the last one, which means flammability will decrease. That means flammability is how easily something catches fire. So, like I said, with the tree example, okay, if you have a very small piece of paper, for example, okay, then now you are moving it up to a tree, correct? From very little number of carbon, maybe 1 carbon, to 4 carbon, okay, the number of carbon increases, size increases, it's harder to actually burn this thing now compared to when it has very little carbon. Okay, so now we have discussed all 4 of them: melting point, melting point, boiling point, viscosity, and flammability. So these 3 things will remain the same for this part, no matter which family we are talking about. Okay, so in the next video, we'll start with alkane.